Today we are going to study method of separation of variables. We know almost all engineering problems is dealing with differential equations, either ordinary differentiation or partial differentiation. If there are more than one independent variable, we have to go for partial differentiation. In your next module, we are going to study the applications of partial differential equation, namely wave equation and heat equation. And here we will derive the wave equation, heat equation. We will solve both the equations. Again, we will do the initial value problems and boundary value problems related to wave equation as well as heat equations. And the method we are using is method of separation of variables. Now, in this case, what we will do is, suppose we have a problem like this. Say Z is a function of x and y. Okay. In this case, here x and y are independent variables. Okay. And Z is the dependent variable. That is, the Z is depending upon the values of both x as well as y. So here there are two independent variables, and so we use partial differentiation. Now the method we use here is, we will take the dependent variable Z as a product of the independent variables. We will use the dependent variable Z as a product of these two independent variables, say x of x and y of y. That means here capital X is a function of x alone and capital Y is a function of small y alone. So, okay, now, and we will take the derivatives required for solving the problem, like first order derivatives, second order derivatives, or any higher order derivatives. We will take that and we will substitute in the concerned differential equation, and then we will separate the variables. Okay, when you separate the variables, we will form two, in this case we will form two different ordinary differential equations. It is not partial differential equations, we are getting two different ordinary differential equations, and you know how to solve the ordinary differential equations. And we will solve both the equations separately and take the product of the solutions as the value of this Z. Okay, so individually we will solve using the methods we have studied in your lower classes. We have studied in your second semester methods involving solving differential equations. You can use any one of the methods to solve the differential equations and we will get the solution. Okay. Now we can do a problem related to method of separation of variables using method of separation of variables. Solve the equation 4 into dou u by dou x plus dou u by dou y equal to 3u. Subject to the conditions, when x equal to 0, u equal to e raised to minus 5y. This is the problem. Now, as I have already told you, in this method we use the dependent variable as a product of the independent variables. Here you see x and y are the independent variables involved in the problem and u is the dependent variable. So we will take the trial solution as, let u, which is a function of x and y, we will take u as the product of, say, x of x and y of y. That is the product of function of small x, function of small y. Okay, now take this equation as equation number 1. Then we need dou u by dou x and dou u by dou y. What is dou u by dou x? Dou u by dou x is differentiating u partially with respect to x, that is x dash y, and dou u by dou y is differentiating u partially with respect to y, x y dash. Remember, when you do the partial differentiation, when you differentiate partially with respect to a particular independent variable, we have to treat all other independent variables as constants. Now substitute here. Then what happens to our equation 1? It becomes 4 into x dash y plus xy dash equal to 3 capital X y. Now we will divide throughout by capital XY. So this becomes 4 into x dash y by xy, which is x dash by x, plus xy dash by xy, which is y dash by y, equal to 3. Okay, now we will rearrange this as, say, 4 into x dash x equal to 3 minus y dash y. Now look at this. Here left side is a function of x alone, where capital X is a function of x. It can be like sin x, e raised to x, or combination of any functions. It is a function of x alone, left side, and right side is a function of y alone. Okay, now x is here only and y is in the right side, and we all know x and y are independent variables, and when you equate like this, we can say that this is nothing but a constant. Okay, so take that constant as small k. Okay, the left side is a function of x alone, small x, and right side is a function of small y alone, and both are independent variables. Hence, this we can equate to as a constant. Okay. Now, this is the equation we got after substitution. Okay, and here we will solve this. That is taking 4x dash by x is equal to k. We will equate these two. So this becomes, say, or you can take this as x dash by x is equal to k by 4. Now integrate this. So on integration, the numerator is the derivative of the denominator. So the integral of this is what is that? Now integrating this, we get this as log capital X equal to k by 4 into small x plus, say, log c1, constant of integration. Now remember, the variable of integration here is small x, not capital X. Capital X is a function of small x. Like if it is like, for example, capital X is like, say, e raised to x into x square or something like that. Now what is x then? Capital X equal to c1 e raised to kx by 4. Take this as equation number 2. Now again take these two. 3 minus y dash by y equal to k, or we will rearrange this as y dash by y is equal to 3 minus k. Y dash by y is equal to 3 minus k. Again integrating with respect to y. Here we have integrated with respect to x. Here we can integrate with respect to y. So this becomes log y equal to 3 minus k into variable of, we are integrating with respect to small y. So it is into y plus log c2. Okay. Now what is capital Y then? c2 e raised to 3 minus k into y. Take it as equation number 3. Now substitute the values of capital X and capital Y in our trial equation. So u of x comma y, which is our capital X into y, becomes c1 e raised to kx by 4 into c2 e raised to 3 minus k into y. Or you can write c1 into c2, we can replace by, say, capital A, e raised to kx by 4 plus 3 minus k into y. This is our solution. But our problem is not ending here. We have to do the solution for the initial condition given. What is the initial condition? When x equal to y, when x equal to 0, our u was e raised to minus 5y. Our initial condition was when x equal to 0, u equal to e raised to minus 5y. We have to substitute here. Now when x equal to 0, that is e raised to minus 5y equal to a into e raised to 0 plus 3 minus k into y. So that is a e raised to 3 minus k into y. Now equate left side and right side. E raised to minus 5y equal to ka into e raised to 3 minus k into y. Now the coefficient when you equate this gives a equal to what? 1. A equal to 1, and when you equate the exponents, we get 3 minus k equal to minus 5, or k equal to k up will go to this side. 3 plus 5 which is 8. So we got k equal to 8. Now what happens to our solution? Our solution becomes u of x comma y is equal to, which was a into e raised to, what was that? Kx by 4 plus 3 minus k into y becomes 1 into e raised to, k is 8 x by 4 plus 3 minus 8 into y, which is nothing but u of x comma y equal to e raised to 2x minus 3 minus 8 is minus 5y. So this is our required solution. So this is the solution of the problem. Now the same problem, that is the same question, we will do with some other initial condition. We will arrange the question like this. Now here, next problem is, using method of separation of variables, solve 4 into dou u by dou x plus dou u by dou y equal to 3u, subject to u equal to 3 into e raised to minus y minus e raised to minus 5y when x equal to 0. And you might have noted this is the same problem, but the only difference is the initial condition. Now in the earlier case, the change was u was e raised to minus 5y when x equal to 0. Here there was two terms. Okay, now let us see how we will do the solution. Here also we will start the same thing. Let us take u of x comma y, the independent variable, as the product, the dependent variable as the product of the independent variables, capital X of x into capital Y of y, and in that case we got the solution as u of x comma y is equal to, what was it? A into e raised to kx by 4 plus 3 minus k into y. This was the solution we got. Now here, now we have to apply the initial condition, that is when x equal to 0, u equal to 3 e raised to minus y minus e raised to minus 5y. Now when you do this, we get 3 e raised to minus y minus e raised to minus 5y equal to a into e raised to, when you put x equal to 0, this becomes 0, 0 plus 3 minus k into y, or that is a into e raised to 3 minus k into y. Now that is 3 e raised to minus y minus e raised to minus 5y equal to a into e raised to 3 minus k into y. Now how will you get the value of a and k? Here left side involves two terms, that is like a binomial, and right side is involving only one term, like a polynomial, monomial. Now here you can't take a is equal to 3 or a equal to minus 1, or you can't take any common factor out of this. So in this case, the problems like this, what we will do is, we will take here, we will take the solution u of xy as the sum of two independent solutions separately. That is, now for this case, our area solution was u of x comma y is equal to a into e raised to kx by 4 plus 3 minus k into y. This was our solution, trial solution. Now we will write this u as sum of two independent solutions like this, u1 plus u2, where u1 equals, say we will take like this, a1 e raised to k1 x by 4 plus 3 minus k1 into y. Similarly, what will be u2? u2 will be, just instead of a1 we will put a2 instead of k1 we will put k2x k by 4 plus 3 minus k2 into y. Okay, now what is our new revised u of xy is sum of these two, that is a1 e raised to k1 x by 4 k1 x by 4 plus 3 minus k1 into y plus a plus a2 into e raised to k2x by 4 plus 3 minus k2 into 1. This is our new trial solution. Now we have to apply the initial conditions based on this equation. So what was our initial condition? When x equal to 0, u was, when x equal to 0, u is 3 e raised to minus y minus e raised to minus 5y. Okay. Now when x equal to 0, u is this 3 e raised to minus y minus e raised to minus 5. Now substitute here. That is 3 e raised to minus y minus e raised to minus 5y equal to a1 into e raised to, when x equal to 0, this becomes 0, plus 3 minus k1 into y plus a2 into e raised to, again when x equal to 0, this becomes 0, 0 plus 3 minus k2 into y. So we are getting this as 3 e raised to minus y minus e raised to minus 5y equal to a1 e raised to 3 minus k1 into y plus a2 e raised to 3 minus k2 into y. Okay, now left side involves 2 terms, right side also 2 terms. In the earlier case it was a monomial, I think. Here we got 2 terms. Now equate any 2 terms, either the first term with the first term and second term with the second term, or vice versa, anything you can do. Now here I will write a1 e raised to 3 minus k1 into y is equal to 3 e raised to minus y. Now equate also a2 e raised to 3 minus k2 into y as, what is that? Minus e raised to minus 5y. Now equate the corresponding terms. Equating the coefficients, we get a1 equal to 3. Now equating the exponent parts, we get 3 minus k1 equal to minus 1. So what is k1? K1 equal to 3 plus 1, which is 4. So k1 we got it as 4. Now again coming to this one, equate the coefficients, a2 equal to minus 1 and 3 minus k2 equal to minus 5, or k2 equal to 3 plus 5, which is 8. So we got k2 equal to 8. So what are the values? a1 equal to 3, k1 equal to 4, a2 equal to minus 1 and k2 equal to 8. So you can write the equation as, so what was our solution? It was u of x comma y is equal to a1 into e raised to k1 x by 4 plus 3 minus k1 into y plus a2 into e raised to k2 x by 4 plus 3 minus k2 into y. Now substitute the values of a1, a2, k1 and k2 here. So this is 3 e raised to k1 is 4, 4x by 4 plus 3 minus 4 into y plus, now a2 is minus 1, it is minus 1 into e raised to k2 is 8, 8x by 4 plus 3 minus 8 into y. Now simplify this. What is our solution? So our required solution is u of x comma y is equal to 3 into e raised to x, 3 minus 4 is minus 1, so minus y, minus e raised to 8x by 4 is 2x, 3 minus 8 is minus 5. This is our solution. Okay, now we can do more problems on our interaction class sessions. So we will do this type of more problems on that. Thank you.